May 14th, 2026. Russia's state aerospace conglomerate Rostec announced that its domestically built PD-8 turbofan engine had finally wrapped up the full certification process, closing out a testing campaign that had run for months and at multiple earlier points appeared genuinely at risk of falling apart entirely. This wasn't a minor bureaucratic formality. It was the culmination of a genuinely difficult engineering effort, one that had already blown through its original certification deadline by roughly 6 months, plagued by a serious thrust shortfall that industry sources had only quietly acknowledged months earlier. The engine that just passed certification is meant to power Russia's most important post-sanctions civil aviation project, a Russified version of the Sukhoi Superjet, now rebranded as the SJ-100, built specifically to fly without a single French-supplied part inside its engines. But here's what this story genuinely isn't. It has absolutely nothing to do with Boeing. This is a 100-seat regional jet, a category Boeing doesn't build, has never built, and has no plans to build. If anyone should be paying close attention to this milestone, it's Embraer, not Boeing. And even Embraer likely isn't losing much sleep over it either. Let's establish exactly why this engine needed to exist in the first place, because the backstory here is genuinely revealing about how deeply Western sanctions cut into Russia's civil aviation sector after 2022. The original Sukhoi Superjet 100, Russia's first genuine post-Soviet attempt at building a modern commercial jet, never actually flew on a purely Russian engine at all. According to Wikipedia's detailed history of the power plant involved, the Superjet's original engine, the SAM-146, was developed and produced by a company called PowerJet, a 50-50 joint venture created in 2004 between France's Snecma, a Safran subsidiary, and Russia's own NPO Saturn. PowerJet operated 2 separate production sites, one in Villeroche, France, and the other in Rybinsk, Russia, with the 2 countries' engineers working side by side for close to 2 decades to design, build, and support this shared engine. That entire arrangement collapsed the moment Russia invaded Ukraine. According to that same source, PowerJet was formally dissolved in March of 2022, and with it went Russia's entire supply chain for keeping its own flagship regional jet flying, since half of every single engine's critical components and ongoing technical support had always come directly from France. That collapse left Russia with a genuinely urgent problem. An entire existing fleet of superjets, already flying passengers across the country, suddenly cut off from the French half of the technical support and spare parts pipeline that kept their engines running. The PD-8 program is Russia's answer to that exact crisis. And according to Aerotime's detailed reporting on the engine's recent certification, it's being developed specifically as a domestically built replacement for the Franco-Russian SAM-146, intended to power the SJ-100, the import-substituted, fully Russified version of the original Superjet. The technical lineage of the PD-8 traces back to an existing, larger Russian engine family. According to that same Aerotime reporting, the engine integrates 17 distinct new technological developments, including high-pressure turbine blades and nozzle assemblies built from alloys with greater heat resistance than those used on the larger PD-14 engine, the same domestic engine Russia has separately been forced to adopt for its MC-21 passenger jet program after losing access to Western engines there as well. The PD-8 essentially borrows its core architecture directly from that larger PD-14 design, scaled down specifically to fit the smaller Superjet airframe. The actual specifications of the finished engine, according to detailed reporting from RU Aviation, describe a power plant rated at 17,600 pounds of thrust, developed by UEC Saturn specifically for both the Superjet 100 and, longer term, for Russia's Beriev B-200 amphibious firefighting aircraft. Aerotime's own technical breakdown adds further detail. A 2-spool turbofan design in the 8-ton thrust class with a bypass ratio of 4.4, and what the report describes as a fully Russian electronic control system, a detail worth noting specifically because it signals Russia's deliberate effort to eliminate not just French mechanical components, but any Western-sourced software or control electronics that might create future vulnerabilities to sanctions or export restrictions. Now here's where the real, honest story gets considerably more complicated than a simple triumphant certification announcement would suggest, because this program's actual path to completion was genuinely rocky and worth understanding in detail before taking any celebratory framing at face value. According to reporting from ePlane AI dated March 2026, the PD-8's certification timeline had already slipped significantly by that point. Originally planned for November of 2025, certification had already been postponed to the first quarter of 2026. And the reason behind that specific delay was genuinely serious. Reports from within the Russian aviation industry, cited by the publication Business Online in December of 2025, indicated the PD-8 engine simply wasn't producing the thrust needed to support flights with a fully loaded passenger cabin. A separate Russian language report on the same issue, dated January 2026, confirmed the specific technical detail. The engine's thrust at maximum takeoff mode measured 8,056 kilograms force, and crucially, flights with a full passenger cabin were, in that report's own words, currently excluded as a result. Think about what that actually means in plain terms. Russia's replacement engine for its own regional jet, at the exact moment it was supposed to be entering final certification, couldn't yet reliably generate enough power to safely lift a fully loaded plane full of passengers and their luggage off the ground. That's not a minor paperwork delay. That's a fundamental performance shortfall in the engine's core job, discovered at an uncomfortably late stage in the certification process. And it forced Russian engineers to go back and specifically address the thrust problem before certification could move forward at all. To Russia's genuine engineering credit, that problem appears to have been legitimately successfully resolved, and the subsequent testing regimen that followed was genuinely rigorous, not simply rubber-stamped to hit a politically convenient deadline. According to RU Aviation's detailed coverage, the PD-8 successfully completed a full 150-hour certification test run at maximum operating conditions, conducted over approximately 6 weeks at UEC Aviadvigatel's test stand in Perm, with the engine accumulating the equivalent of more than 6 continuous days of sustained operation. Deputy Chief Designer Artem Bodernikov described the test conditions directly. During certification, the engine was subjected to extreme loads to verify its operational safety under real-world conditions, with all critical parameters, including rotor speeds, gas temperatures, and fuel and oil pressures, deliberately pushed to their limits simultaneously alongside maximum thrust output, specifically to confirm the engine could handle worst-case operational scenarios rather than just comfortable idealized test conditions. Aerotime's broader reporting on the certification process fills in additional detail about just how extensive this final testing campaign actually was. Beyond the 150-hour maximum load endurance run, the engine also underwent a fan blade-off test in December of 2025, a deliberately destructive test that simulates a catastrophic fan blade failure to confirm the engine's containment structure can safely handle that exact kind of emergency without endangering the aircraft. It also completed water ingestion trials in November of 2025, bird ingestion tests to confirm the engine can survive a real-world bird strike without catastrophic failure, and natural icing flight tests conducted in the Arkhangelsk region of Russia in March of 2026, specifically to validate the engine's performance in genuine cold weather flying conditions rather than simulated ones. Fyodor Mironov, UEC's Deputy Director for Sales, offered a confident assessment following the completion of this full testing regimen. This Russian engine has demonstrated high reliability and safety, even under critical conditions. So where does this leave the actual practical rollout of the aircraft this engine is meant to power? This is exactly where the change everything, or Boeing didn't expect framing, collapses most clearly under the weight of the actual documented timeline. According to TASS's own reporting from May 14, 2026, the same day the certification milestone was announced, Russian First Deputy Prime Minister Denis Manturov was careful to separate engine certification from the aircraft actually reaching customers. We assume that the Sukhoi Superjet aircraft will receive this engine once the overall aircraft certification is obtained, Manturov told reporters, adding that deliveries of the SJ-100 with its new domestic engine will begin either at the end of this year or in the first quarter of 2027. A separate, even more recent source, RU Aviation's own news archive, shows a specific entry from June 25, 2026, titled SJ-100 Certification Timeline Revised to Late 2026 Q1 2027, confirming that even after the engine's own certification was completed, the broader aircraft-level certification process, meaning the complete SJ-100 as a whole flying platform, remained an entirely separate hurdle still being finalized as of that date. The scale of what this program is actually building toward, in terms of real aircraft numbers, is worth putting into honest perspective as well, because it's genuinely modest compared to the scale of Boeing and Airbus's own commercial operations. According to Wikipedia's coverage of the aircraft, Aeroflot, Russia's flagship carrier, ordered 89 of these Russified aircraft back in 2022, the primary confirmed order underpinning this entire program. 89 aircraft for Russia's own domestic flag carrier is the scale we're actually discussing here, not some sweeping international order book position to disrupt Boeing's global market share. And there's a further complication buried in even that modest order that adds real uncertainty to how quickly those 89 aircraft will actually reach service. According to Flight Global's reporting from earlier this month, Russian industry has been separately weighing whether to retrofit existing, already flying superjets, the ones still using the original French-linked SAM-146 engine, with the new PD-8 instead, specifically as a way of keeping those older jets operational without needing brand new SJ-100 airframes at all. That same reporting cites Russian business publication Kommersant's estimate that United Aircraft believes roughly 50 existing superjets, about a third of the entire in-service fleet, could realistically be re-engined this way at a total estimated cost of 115 billion rubles, roughly $1.5 billion, with initial engine replacements not expected to even begin until late 2029. And Russia's own industry minister, Anton Alikhanov, quoted as saying the actual final number of aircraft that will undergo this retrofit has not been determined. There's an even more sobering piece of context worth including here, one that speaks directly to why Russia needed this domestic engine program to succeed in the first place, beyond simply escaping French supply chain dependency. That same E-Plane AI reporting from March 2026 references a separate, deeply concerning wave of incidents that had nothing to do with the PD-8 specifically, but everything to do with the broader state of Russian civil aviation safety under sustained sanctions pressure. Citing reporting from the Moscow Times, the article describes how, within a single week in March 2026, 5 separate Russian passenger aircraft experienced mid-flight engine failures, including one incident on March 16th, where a Sukhoi Superjet 100 operated by Rossiya Airlines was forced to turn back to Sheremetyevo Airport after experiencing a technical malfunction mid-flight. That kind of safety pattern, 5 engine failures across Russian carriers in a single week, adds real, tangible urgency to why getting a reliable, properly certified domestic engine into service matters so much for Russia specifically, quite apart from any question of international market competition. There's one more genuinely notable detail worth including, because it reveals exactly which international market this entire program is actually oriented toward, and it isn't the traditional Boeing and Airbus customer base at all. According to Aerotimes reporting, UAC, the SJ-100's manufacturer, signed a memorandum with India's own Hindustan Aeronautics Limited back in October of 2025, specifically to explore licensed assembly of this regional jet within India. And RU Aviation's reporting separately notes that an SSJ-100 powered by PD-8 engines was actually showcased at the Hyderabad Air Show in India in late January of 2026. That pattern lines up precisely with everything already established about the broader trajectory of Russia's post-sanctions aerospace industry. Not a program aimed at competing head-to-head with Boeing and Airbus in traditional Western markets, but one increasingly oriented toward partnerships with India, alongside the broader pivot toward non-Western markets already documented across Russia's other aviation and defense programs. So what's the fully accurate, evidence-based version of this story, once you strip away the Boeing didn't expect framing entirely? Russia genuinely did achieve something real and technically significant here, successfully completing certification of a domestically built turbofan engine after overcoming a genuinely serious thrust shortfall discovered late in the program through a rigorous multi-month testing regimen including blade-off tests, bird and water ingestion trials, and cold weather icing flights. That's a legitimate engineering accomplishment, and a genuinely important one for Russia's own domestic aviation industry, which has spent years scrambling to replace Western components across nearly every major civil aircraft program it operates. But the engine powers a 100-seat regional jet, destined primarily for Russia's own domestic flag carrier, with total confirmed orders sitting at 89 aircraft in a market segment Boeing has never competed in at all. Actual aircraft deliveries remain pushed out to late 2026 or early 2027 at the very earliest. A broader retrofit program for existing superjets won't even begin until 2029 by the manufacturer's own estimates. And the program's clearest path toward any meaningful international growth runs not toward Western markets, but toward a licensed assembly partnership with India. Whatever this milestone represents, and it does represent something real, it isn't a story about Boeing being caught off guard by anything. Here's an extended, fully accurate script on the same PD-8 story, filling in the competitive picture that Boeing didn't expect leaves out entirely. Who this engine actually competes against, why a deadly 2024 crash accelerated the whole program, and how modest Russia's own realistic export ambitions actually are. There's a tragedy sitting underneath this entire engine program that rarely makes it into the celebratory coverage, and it explains the genuine urgency driving Russia's push to finish the PD-8 far better than any talk of national pride or aerospace prestige ever could. According to detailed reporting compiled by Who That Plane, examining the Superjet's operational history, an SSJ-100 crash resulted in the deaths of 41 of the 78 people aboard, and Russia's own Interstate Aviation Committee published its final investigation report in March of 2025, directing specific safety recommendations at crew training programs, the aircraft's original designers, and air navigation services. That same detailed history lays out just how severe the parts crisis became following the 2022 invasion. Roughly 55 to 60% of the original SSJ-100's total cost came from Western-sourced components, including Thales avionics, a Honeywell auxiliary power unit, and SAM 146 engine parts, every single one of which was suddenly cut off from any legitimate supply channel the moment sanctions took effect. Airlines operating the existing Superjet fleet were left with brutal, unsafe options, cannibalizing already grounded sister aircraft for spare parts or sourcing components through unofficial third-party intermediaries of uncertain reliability. That combination, a fatal crash under investigation, and an entire existing fleet increasingly dependent on gray market parts just to keep flying safely, is the real backdrop that made finishing the PD-8 an urgent safety necessity for Russia, not simply a matter of national industrial pride. The actual development timeline for getting to this point stretches back further than most recent coverage suggests, and it's worth tracing the full arc to understand just how long this specific engineering effort has actually taken. According to Aviation File's detailed reporting, the very first prototype, SJ-100, equipped with PD-8 engines, completed its maiden flight on March 17, 2025, more than a year before the engine itself finally passed formal certification. Separate reporting from Defense Mirror describes an even earlier milestone, aircraft serial number 9-7004, described as the first Superjet built entirely with serial production technologies in its intended final configuration, remaining airborne for roughly an hour during its own test flight, with the manufacturer noting at the time that 24 serial aircraft were already in various stages of production. And Flight Global's coverage of the actual certification announcement in June of 2026 reveals that even completing engine certification didn't mean the aircraft itself was anywhere close to finished. Deputy Prime Minister Vitaly Savliev told reporters that the SJ-100 as a complete aircraft was, at that point, still only about 80% through its own broader certification campaign, meaning a full fifth of the aircraft level testing and approval process remained outstanding even after the engine itself had cleared its own separate hurdles. Rostec's own leadership used the certification announcement to lay out genuinely ambitious future plans for the engine beyond just this one aircraft, and those plans are worth taking seriously as a signal of how central this specific engine has become to Russia's broader aerospace strategy. According to that same Flight Global reporting, Rostec chief Sergei Chemezov described the SJ-100 as poised to become the backbone of regional aviation in Russia, and revealed that the PD-8 architecture itself is being positioned as the foundation for an entire family of related engines, potentially scaled up by 25 to 30% more thrust, or scaled down by 20% less, depending on whatever future application requires it. Chemezov specifically mentioned plans for a 10-ton thrust version intended for business aviation use, and confirmed that designers are separately working on a helicopter variant, designated the PD-8V, intended to eventually power the massive MIL Mi-26 heavy-lift helicopter, one of the largest helicopters ever put into series production anywhere in the world. That's a genuinely significant vote of confidence in the underlying engine architecture, suggesting Russia's engineers view the core PD-8 design as sound enough to build an entire extended product family around it, well beyond just this one regional jet application. Now, to the competitive picture itself, because this is exactly where the Boeing didn't expect framing falls apart most completely under any real scrutiny. According to Bolt Flight's detailed industry analysis, the SJ-100 continues to compete in a space dominated by long-established players like Embraer and Mitsubishi's SpaceJet, explicitly naming the actual manufacturers this aircraft is realistically positioned against. Embraer, the Brazilian aerospace giant, has spent decades building a dominant global position in exactly this 100 to 150-seat regional jet category with its E-Jet and E-2 families, aircraft already flying for airlines across dozens of countries with a mature, trusted global support network behind them. Mitsubishi's SpaceJet program, formerly known as the MRJ, represents a cautionary tale worth remembering in this exact context. Despite enormous investment and years of development by one of the world's most capable industrial manufacturers, that program was ultimately suspended entirely in 2023 after failing to achieve certification, a sobering reminder of just how difficult breaking into this specific aircraft category genuinely is, even for a company with vastly more international aviation experience and Western market access than Russia's own aerospace industry currently has. That same Bolt Flight analysis is refreshingly candid about the SJ-100's actual realistic prospects outside Russia's own borders. International traction remains constrained by lingering concerns over reliability and ongoing geopolitical complications, a diplomatic way of acknowledging that years of sanctions, a fatal crash investigation, and Russia's broader international isolation have left the aircraft facing genuine, well-founded skepticism from any airline outside Russia's own sphere of influence that might otherwise consider buying it. And when you look at exactly which international markets Russian aviation analysts themselves are actually targeting for this aircraft, the picture that emerges is a far cry from anything resembling global disruption of Boeing's business. According to reporting citing aviation expert Andrei Velichko, the countries where the domestic SJ-100 is expected to find genuine interest are specifically former Soviet states: Kazakhstan, Uzbekistan, and Belarus, nations Velichko describes as having historically formed comparable regional transportation patterns to Russia's own domestic network. That's the honest, realistic export market Russian industry analysts themselves are pointing to, not a fleet of European or Asian flag carriers defecting from Boeing and Airbus, but a handful of neighboring post-Soviet countries with closely aligned aviation infrastructure and existing political ties to Moscow. There's a genuinely striking historical irony buried in how far this program's own ambitions have shrunk over time, one that puts today's modest, regionally focused export targeting into sharp relief. According to Wikipedia's detailed history of the original Superjet program, back when Sukhoi first launched this aircraft in the early 2000s, the company's own stated ambitions were vastly larger. Sukhoi anticipated a market for 600 aircraft by 2020, representing what it projected as a full 10% of global demand for regional jets at the time, worth an estimated $11 billion in total sales. That same early documentation describes serious discussions held with Air France and the SkyTeam Airline Alliance specifically to ensure the original aircraft would meet Western market requirements, and a formal application for European EASA certification submitted all the way back in 2004. Compare that original, genuinely global ambition, courting major Western airline alliances and chasing 10% of the entire worldwide regional jet market, against where the program actually sits today. An aircraft whose most optimistic realistic export prospects, according to Russia's own industry analysts, extend only as far as Kazakhstan, Uzbekistan, and Belarus. That's not a story of an engine changing everything for Boeing. It's a story of a once genuinely internationally ambitious aircraft program gradually shrinking over 2 decades and 1 full-scale war down to a considerably more modest, defensively oriented goal, simply keeping Russia's own domestic regional aviation network flying safely on parts nobody else in the world can cut off at all.